name is Tony, and today I will be presenting the Grand Challenge final project. We have Arayan, Chen, Mu, and Mengxiong also contributors of this project. So our Grand Challenge is designing a fair and responsible AI. And why is this important? This is important because we want an automated and scalable impact artificial intelligence system for the real world opportunities and manage the risk. Also, we want an automation and scaling of historical bias, and the AI system need to balance fairness, accuracy, transparency, and performance. Some of the societal outcomes are the consequence of modeling, abstraction, and governance selections. So we wrote down three different specific area of designing a fair, responsible AI, which is AI justice and algorithmic bias. Let's make sure that the AI system actually treat people equally with different groups, because AI learns from historical data and it can repeat old inequalities. Also, the goal is to identify these patterns and adjust the system to give a fairer outcomes. The second thing we will be touching is the abstraction and trade-off control in AI design. AI turns complex human behavior into simplified data and categories. So when we simplify, we lose details that matters. Designers have to manage trade-offs such as a fairness versus accuracy or inclusion versus efficiency. This area examines how those choices affect different groups. And the third thing we'll be talking about is the transparency and accountability of the AI. So many AI systems are very difficult to interpret, which makes it hard to understand why a decision was made. Without a clear explanation, it is challenging to detect bias or help someone who was harmed by an incorrect output. This area works on making the model more understandable and ensuring responsibility when issues occur. So what happens if we don't fix this? There will be structural inequalities in our system. User will begin to lose trust in AI-driven decisions. Organization and businesses will face ethical, legal, and reputational consequences.
Next, I would like to introduce Grand Challenge 1, which focuses on the core problem: AI system must treat people equally. The problem begins with the data AI is trained on. Many AI databases include historical documents that contain discrimination and prejudice. Because AI learns patterns directly from data, it can also learn the bias assumptions embedded in these texts or images. As Kaleskin wrote in 2017, applying machine learning to ordinary human language result in human-like semantic biases. Similarly, Steed in 2020 found that machine learning models can absorb stereotypes simply from the way people are portrayed online. These biases exist also because historical documents were preserved for authenticity, even if their values are not acceptable today. Like, as a result, AI may unintentionally reproduce social inequalities that exist in the past. And the impact of this problem is very significant. If government, schools, or businesses make decisions using biased AI systems, such as in hiring, credit scoring, or public opinion analysis, certain groups may be systematically underestimated or excluded. And when the public sees discriminatory AI outputs, they may lose their trust in the fairness and legitimacy of technology. And beyond that, biased AI can also cause emotional harm and reinforce long-standing social traumas. And to address these issues, we propose three key solutions. First, we should improving the quality and fairness of training data. We must review data sets, and identify biased contents and providing clear historical context for them. This helps prevent AI from simply copying these harmful patterns. And second, fairness-focused model design is another solution. During training, developers can add fairness constraints or use automatic debiasing instructions, so the model learns to avoid decisions that disadvantage certain groups. And finally, strong human oversight and governance are very important. Experts should regularly audit AI decisions, maintain transparency, and evaluate impacts across different populations.
Our second grand challenge's core problem deals with the trade-off between abstraction and the control of AI. AI tools are essentially getting too abstract, meaning results are generated without explanations. We don't know the actual algorithm the AI is taking, because AI is basically designed upon inputs and outputs, where traditional algorithms are designed on inputs. We make a human-designed algorithm, and we get certain outputs. And these unknowledgeable users continue to send messages compounding on these wrong concepts, causing a prospect we call query hell, as described in a research study conducted by Zhai. AI is also, at most times, non-contextual, meaning they don't understand the project specifications and requirements of the specific project you're working on. Also, users start to interact more with the results in the process, which especially becomes bad in learning environments. With easier usage, though, understandability and control over technology becomes more difficult. So on the right, we could see a real-world example of this. And A hidden model behavior essentially correlates to unintended results due to lack of specificity. So this includes, as to the right shown, beginner code debugging, which may cause core problems in like a program's database because the AI doesn't know what the other systems that are attached to it are, and summarization and no-step answers. Additionally, in the new generation style of learning, as I previously described, actively using AI to accomplish tasks in study diminishes growth by constraining humans to their domain's limited scope of expertise and undermines people's critical thinking skills, since people just blindly trust results they can't verify. So to counter this, we propose a three-tier solution, investigating more human-in-the-loop design architectures which prioritize humans as decision makers, increasing robustness of non-AI online resources like Stack Overflow, Reddit, online communities, just in general, and expansion of AI usage guides and interpretability tools, which will be particularly made by AI and ML researchers and policymakers. Then we also encourage the general people to make AI an assisting tool rather than for learning and exploration. By pushing forward this agenda, we solve the problem of AI causing essentially learning to be dumbed down in Gen Z, and we also create critically thinking students.
The next grand challenge is how do you ensure transparency, explainability, and accountability in AI systems? First of all, transparency and explainability are tightly interconnected. They work together to build trust among users and prevent bias. When organizations openly communicate in AI systems' capabilities and risks, they enable the full usage of their potential. However, the model's data and sources are often hidden, and many organizations lack proper documentation resources. Second, AI models often encapsulate the entire decision-making process, which makes it difficult to see why they produce certain outputs. Nonetheless, some models are beginning to include mechanisms to explain their logic. Finally, accountability becomes harder as AI systems grow more complex. They use algorithms to generate output, which do not undergo a review process.
And for the impact of the third one challenging, I think the impact of the poor derivation and explanation in AI system can be very serious. And on an individual level, people may be denying jobs, loans, or medical treatment without ever knowing why a system made that decision. And without explanations, users cannot challenge or appeal unfair outcomes. And on a larger scale, hidden errors in complex AI systems can cause widespread harm, especially in high-risk areas like healthcare, transportation, and criminal justice. When people do not understand how decisions are made, their trust in AI technologies continues to decrease. So for companies and organizations, the lack of explainability can result in legal consequences, ethical violations, and major reputational damage. Governments also face difficulty regulating AI systems when responsibility is unclear. Overall, without transparency and explanation, AI system can quietly cause large-scale damage while avoiding accountability.
To address this challenge, developers, publishers, users, and other relevant parties should share the responsibility of ensuring accountability. Third-party auditors may also be introduced to assess AI models. Another key critical step in guaranteeing transparency is standardizing data documentation and reporting. Explainable AI, or XAI, can assist in revealing the model's logic in readable language. Finally, the government should establish regulatory bodies that monitor AI systems, mandate the sharing of training data, and encourage.
So now let's touch on the conclusion. So overall, we have learned that AI fairness is actually important because the system now has such a great impact on decisions like errors in healthcare, hiring, and education. If we don't take action with these biases, AI can continue to make these same inequalities that already exist in our society. So what we have learned so far. So our three subtopics have helped explain why this is a problem. So it's very complicated as AI fairness and algorithmic bias shows how unfair patterns can appear when models learn from historical data. Abstraction and trade-off control reminds us that the choices we make while simplifying human experience into data can impact who benefits and who is being overlooked. The third thing is the accountability of AI, which helps us understand why it is necessary to know how AI makes decisions and who should take responsibility when something goes wrong. The final takeaway of this topic is that together, these ideas show that create a fair AI is necessary and requires a thoughtful design that understanding both technical and social issues. By addressing all three areas, we move closer to an AI system that is more trustworthy and fair for everyone to use. Yeah. And here is the works cited that we listed all of the sources that we used. Thank you very much for listening.